This video is sponsored by Hunter Engineering. Visit hunter.com for more information.
From the Aishan Broadcast Studio, it's What's Treading, brought to you by Hunter Engineering.
Hello and welcome to What's Treading. My name is David, and on today's episode we have a very special in-studio guest. His name is Harmen Van Kamp. He is the CEO and co-founder of Global Air Cylinder Wheels. Harmen, thanks for coming in.
Thank you, David.
So I want to get right to the heart of the matter here because, when I first started looking up your technology in these air suspension wheels, very first glance, I think, oh, I've seen that before. This is, nothing I haven't seen before. Maybe they're just doing something a little bit different, but you dig into just past the surface and no, this is completely different. Can you explain to us what is this product that you've developed?
Yeah, absolutely. So, you got to look under the skirt a little bit to see what's the difference. But what I always say is everything you know from a rubber tire, you need to forget it. And we're looking here at a mechanical wheel structure. So it doesn't behave like a rubber tire does. Its economics are different, the way it's made. It's a mechanical wheel structure, which basically replaces the rubber tire and the rim. And the outer drum is a solid piece of steel structure. And between the rim and the drum, we create the suspension system through air cylinders. So instead of having just deflection at the bottom, the vehicle actually floats inside that wheel. So you have a steel structure on the outside, a rim, and between the two, we actually allow for the deflection through air cylinders instead of air in a rubber tire.
And it's pretty incredible. I mean, as you said, you kind of have to look under the surface a little bit to really understand what's going on there. Because at first glance, it almost looks like an airless tire that you may have seen with the inner structure and everything, but that's not at all what's going on here. So my understanding is OTR is really what you're focused on here for this product, and that you're actually undergoing a little bit of testing right now in Minnesota. What are you looking for out there?
So that's right. So a lot of people look at it and they say, oh yeah, another airless tire or wheel for that sense. But indeed, it's very different. And the reason why we started OTR is we had to look at the markets and see where is the tire a limiting factor or a safety issue, for example, where OTR, mining is very quickly identified as, okay, that's a huge issue, not only on costs, but safety and definitely environment. Those are really the three big things. So we've identified about 26 benefits for mine sites, but not everything applies to every mine site because of climate conditions, different applications, etc. Our main thing really is three items that we're looking at. It's the environment, safety, and cost, because that applies to absolutely everybody.
Sure.
What are we doing here with the testing? It's R&D, obviously. So, tires have taken 135 years to get where we are now, and they're still R&Ding. We've done this path about 7-8 years, and we really have a viable product now that we can go out and say, look, we've broken this, we've broken that, we fixed it. It's all engineering, which is the beauty of it. Everything can be improved on and engineered for. So what we're looking for really is to prove things such as safety, which we have, environment, but also fuel economy. So there's a fuel saving effect in that wheel. And just getting hours on it and prove to the world that, hey, rubber tires, I always like to bring it back that someone told me, the saying is don't reinvent the wheel or don't reinvent the tire, but you should, and that's exactly what we did. So that's really what we're looking for, to get that out there. We're kind of ready to go a bit bigger now because we've kind of completed the testing that we wanted to do, and take the world by storm.
And so when you're speaking with some of these OTR fleets, what are they hoping to get out of this? I mean, is there one thing that comes up over and over again? Of course, you have your kind of three pillars there, but what are people, I guess, most excited about out there?
Before they try it, the most exciting thing, and it again depends on who you speak to within on the mining.
Sure.
In the end of the day, it's all about money. Okay, so tires together with labor and fuel are the three highest expenses on mine sites. And everything evolves around tires, because without tires, your equipment doesn't work. You don't have any productivity. So the dependency on tires is something that they really don't like, because they're unpredictable. They can blow up. Of course, you can manage it, and you've got the TPMS systems, but you're still very dependent on the tire. So the fact that you can change that and it becomes a mechanical structure that can be maintained just like the vehicle is on, that already is a huge sign of relief for them. Environment, contrast to popular belief, mine sites actually do want to and are cleaning up their act in that sense, and tires is a huge problem. They're typically either just being mulched up on site. They try to do that, but usually they just dig up a big hole and dump the tires in, and that takes decennia, if not longer, to disintegrate. So it's a big problem. It's a high cost as well, and it's environmentally very damaging. So that's a big thing for us as well to really change.
Interesting. Now, when one of these drivers of one of these equipment is actually running on one of these wheels, what does it feel like? I mean, is it going to operate the same way that they're used to, or is it more comfortable? Is it less comfortable? I mean, how do they feel?
Yeah, I like that question, because when people see it on a picture without looking, like you said, a bit closer to what it is, people see just a steel structure, and two big assumptions always: it must be heavier than a rubber tire.
I would assume that.
We'll come back to that point. And the other one is, it must be very painful for your back. Well, we have these attenuators inside that wheel with cylinders. The feedback from the operator is nothing short of phenomenal, and that's the word he actually uses, phenomenal. It's comfier, because you actually have more deflection in our wheel than you get with a rubber tire. And also the type of deflection is different. A rubber tire is linear, where ours is progressively stiffening. So that's just a characteristic of that air cylinder. I always compare it to those restrictors you have on doors. It's easier at the beginning, and it becomes progressively harder to open it. Well, that's what you get. So we're really damping out those the vibrations. Another feedback is, and I like this analogy, is like as if you're driving an Oldsmobile, and very smooth and woolly almost drive, and all of a sudden you're in an M3 BMW race car. You feel more feedback, and the first perception you may have is, hey, I've never felt this before, because you're on tires, but it's positive feedback, because now you can read the road far better.
Sure, yeah.
That was a huge thing. The other one is control. Whereas particularly when you get to these OTR sized tires, that sidewall is a couple of feet high. They actually steer into the corner before they're in the corner, because the delay of the tire. Now, with our wheel, it's instant. So once you touch that steering wheel, your wheel goes where you want it to go. So the feeling of safety there is just tremendous, which makes for tighter turns as well. So we did a turning radius test, and we did it first against rubber tires, and then ours was nearly half the size, which makes for the fact that you can actually go faster around corners, which means more production. It has so many more benefits, of course. So
how does the science work there? How do you accomplish that tighter turn radius?
It's, again, that has to do straight away with that reaction time. So you don't have that delay before that rubber tire comes with you and along with you.
I see. Okay.
Because they're inside that wheel as what we call lateral restraints. They have a little bit of flexibility, but it gives you very much control over, how much sway we can give it.
Sure.
We've given it enough to be comfortable, because you don't want to have a completely rigid wheel, but it's rigid enough to get that straight, turning and more control in that wheel.
I see.
It makes a huge difference, actually.
Now, I want to be clear, you haven't totally eliminated the rubber from the wheel. There is still a tread on there, a rubber compound. How does that work? Is that retreaded once the tread wears out for that particular application, or kind of what's your approach there?
Yeah, so because we bring the suspension system on the inside of the wheel, the requirements of the compound, so a rubber tire is extremely limited, because it needs to be flexible, it can't be brittle, it needs to be able to cope with heat, and we brought that all on the inside of the wheel. So on the outside, we can now, because you take away those limitations, get very creative. We've tried it with steel treads, for applications where you go over hot slag, for example, where tires explode or catch fire. We can put in hard polyurethanes with blended in fire retardant, for example. So yes, on the outside at the moment we're testing with poly. The beauty of it is it now can be changed really to local conditions. Whether it's you want summer shoes, we call them shoes actually, summer shoes or winter shoes, we can put steel butts blended into it. That can change now tremendously because we're not limited to what a tire would give you. Also, the expectations are that once we get that right for every site, because we don't have all the stretching on it and all the compression, decompression, what you get with a rubber tire, because again, it all happens on the inside of the wheel. The life of these treads are much longer than what you'd get out of a rubber tire, because it just doesn't see all those workings on it, what you'd get.
Yeah.
And they're just bolt on, bolt off. So what you do is during a regular maintenance interval of your truck, so it's all about downtime, but the rubber tire, you just don't know when a failure could happen. You put that truck due in for a programmed maintenance interval, whether it's oil service or whatever it is. You take the treads off and you put new ones on, and you're off to the races. So there's no additional downtime due to a tire failure in this case, because it all will be done during your program intervals.
Wow. And so you're getting a longer life of that tire. And in reading your materials, I also noticed rolling resistance is improved. How does that work?
Yeah, there's a few tricks there. The big one is because it's a solid outer structure, is we reduce the contact area. So there is some higher ground pressure. We do stay within what's allowed and what can be done, but it's about 4 to 6 times depending on the underground. If softer underground, it's about 4 times smaller. If it's a very hard underground, it's 6 times smaller ground pressure. That reduces your rolling resistance. That's one. 2, because now, and this is a bit difficult perhaps to, without a visual to understand, but our vehicle floats inside that wheel, which means that once you have a lot of stop goes, the weight of the vehicle actually moves in front of the contact patch area, which means the weight of the vehicle actually pushes down that vehicle itself into motion. So you're in front of the contact area, almost canceling out your rolling resistance. There's obviously, of course, you're still dealing with mechanical resistance, from the engine. We've seen cases, again, this is just done on a wheelchair actually, because the application goes from wheelchairs all the way up to bicycles and cars and OTR. That as long as you keep that weight of the person or the vehicle in front of the contact patch area, you stay in motion, and that has an effect on fuel saving, for example. So that's a very big thing that we're very excited about.
That's super interesting, and let's go to the wheelchairs, the bicycles, the passenger cars. So of course it seems that your main focus currently is that OTR application for good reason. When are you? At what point do you think you're going to really start to focus on some of these other applications as well? Do you feel like you want to kind of prove that OTR space first and then kind of move on, or are you doing these simultaneously?
Yeah, so we're still a small team of engineers, and it requires hundreds, if not thousands, of hours really to understand each segment, each industry, each application. Look at the OTR space. With the small team that we had, it's taken quite a few years to be where we're at. And I get this question a lot, well, why OTR first? Well, because we looked at all the segments and all the industries where this is applicable to. We really looked at where is the tire mostly a restricting factor in operations, which is OTR. That's one reason. The second one is some rules and regulations. Now that comes into play.
Sure.
And every country is then again different. We have about 75, it changes every week almost, 75 issued patents on this. So what we would do is for these particular applications, we would love to license these out. We give you the know-how, you get the rights to use the technology. But the vehicle dynamics now comes into play. Where OTR, it's far more on importance on payload. Where you're looking at, I mean, these trucks carry 240,000 kilos just on payload. Insane. Whereas with cars, all of a sudden now speed becomes an issue, noise becomes an issue. Can it be solved? Yeah, but it requires an awful lot of engineering, and we don't have that knowledge in house. We don't have that capital to do that either, and obviously the testing facilities, we wouldn't have that. So that would be typically done with a partner, be it a rim manufacturer or a chassis supplier, an OEM, or maybe even a tire company says, hey, this is something that we could work with, because we still require that outer padding. There's a whole science to that. But yeah, that's something we're not planning on now, but it's something that we've had some conversations. Let me put it that way.
Yeah, sure. No, I my mind immediately goes to the tire dealer. If your passenger car is equipped with these and you roll in, how does their entire business model change? I mean, it's a whole downstream effect of all these different industries being affected. It could be a really interesting future for you.
Yeah, it's a revolution that's about to start. Let me put it that way. Yeah, it was interesting because when we're on the mine site testing, and we had quite a few representatives from certain companies show up and ask the people on the mine site, well, what's this all about, and how does it look like, and do you think it works? And then the mine site was actually very enthusiastic. Oh yeah, this is working. It's working really well. Should we be afraid? Again, we're not here to kill anyone's business.
Of course.
But we do want to optimize and change something in the tire industry. Again, if people, it was actually National Geographic, this article I found it fascinating. They literally called it the microplastic that you never thought about. People, because it's just a given. Even when you look at the revolution of cars now going all electric, everything gets innovated on, but the tire is still a tire. Of course, there's evolution there, and of course there's better materials, and of course it lasts a bit longer. But the tire is still a tire. Very little thought is put into it. So that's really something that we want to be, changing for the better, because hundreds of millions of tires each year that end up in the oceans, and the wear and tear now. Actually, in Europe, they're not looking that much anymore at the engines. I think they're at tier 7 or 8 now already. The issue now is tire dust and brake disc dust.
Yes, yeah.
And the size of that dust is actually very harmful for us. So something has to change, and it's about time, I think.
Sure.
Presented from the Aishin Broadcast Studio at Babcock's Media.
Now, is the intention that once a vehicle is spec'd with one of these, it's just there? You never have to replace that wheel?
So this is the beauty of it. We engineer things for infinite life. So that you got fatigue curves, and you just go through, okay, this is how many cycles. Let's take the mining example. This is the distance that a truck goes. This is how many cycles you go through. You can calculate all that. You put it in a program called SolidWorks, which is an engineering program. You go through all the what's called finite element analysis, and you can just see, hey, if I put this stress on that component for so many times, will it break? Will it ever break? Or if it breaks, when will it break? After how many cycles? You reach that fatigue life or not. The idea is indeed to have a wheel that is there for the lifetime of the vehicle. So it's designed mechanically just like the vehicle it is. And that's the beauty. We can make it stronger and thicker, and we can change all these things. There is a wear component to it. There always will be, which are obviously the treads, and there's a maintenance component to it. So is it just a wheel you put on and you never look at it? No, I would never claim that. But it becomes a mechanical fix now, rather than the
full replacement.
Full replacement. And I was again, I didn't even know much about this when I started this about 10 years ago. Is think about it. If you look at your own tire, you're aware of the profile, which is how much? A couple of centimeters, or a couple of inches, I should say. But you throw away 90% of the product. It's extremely wasteful. Well, that 90% is our wheel, and then yes, on the outside there is a wear component to it, but far less harmful because we can use different materials now, and it's lasting much longer.
Absolutely, yeah. The steel treads and the all that's a really interesting concept too. Absolutely.
Yeah.
You had brought this up earlier. I want to dig a little more into it. The safety
Yes.
component of this product. So, OTR fleets, obviously their tires is a safety concern, out on mining sites, on other applications.
Biggest.
How, is this something that is are these fleets running into these safety issues often? I mean, are tires exploding on sites? Is this a rare occurrence? Is it a common occurrence?
Well, every tire explosion is one too many.
Of course.
It's very scary. It happens still far too often. Hence, there's these big service companies, and they make big bucks of mitigating the risk, as they call it, or managing the risk. What I always say, hey, stop trying to cover that. Stop trying to mitigate risk. We're actually eliminating the risk. So a couple of scary facts. You're 11 times more likely to die in a tire bay on a mine site than anywhere else in the mine.
Wow.
And mines in general are not safe places to begin with. Hence we got the whole MSHA,
of course,
focused on mining. So that's one. And if you look at I saw an interesting. This was actually from a tire maintenance company on a mine site on a bulletin board. They had a poster, and I asked permission, can I take a picture? Oh, sure, it's public. In a 4100 R57 tire size, which is used on these big cat trucks, 240-ton trucks. There's enough explosive energy. These are it's not high pressure even, it's 120 psi. That's relatively low. But the pressure vessel, that the tire is, there's enough explosive energy in that size tire once it explodes to propel a 200-pound man or woman 11 football fields up in the air. And there's very little insanity between life and death there. So yes, every incident is one too many, and it's sad. It happens way too often still every year, and we eliminate that. We had another occurrence that I heard about on a big loader, a front end loader, and the truck was backing into it to get loaded, and one of these front positions blew up. One person, unfortunately, ended up in the hospital, but the truck driver who was facing away, he said it's like an atomic bomb went off.
Wow. And
the pressure, and they had some administrative offices about 500 yards away. It blew out every single window.
Wow.
500 yards away. It's just, it's incredibly dangerous. So that's a huge thing.
And so of course, with the air suspension wheel, it essentially eliminates the possibility that could even occur.
100%, yeah. And we also, we go through a lot of risk assessments, because that's all mining, get rid of risk and reduce it. If you'd see a risk assessment from a rubber tire, it's blood red. It's, everything is a high risk. And, they're able to, again, manage it, mitigate it. Ours, is not even classified as a pressure vessel anymore. So, you don't have to have special storages anymore. It all becomes mechanical, and everything can be fixed in that sense. Where, I've seen occurrences that a small lodged piece of rock, once it works its way into that tread of a rubber tire, it cuts through everything, even to the beats and the wiring and everything. And it's expensive. These size tires are $70,000, $80,000. So that's actually a question I get a lot. On weight, that's one, but also must be expensive. Well, the upfront cost obviously is a bit more, but the total cost of ownership is ridiculously low, because you put it on there. If I may, an example on these trucks, you buy these big trucks, they're $4 or $5 million, but over the lifetime of that vehicle, once you get that truck on site, it first of all doesn't even come with tires. You put on $500,000 worth of tires and rims. But over the lifetime of the vehicle, you spend $6, $7, $8 million in tires alone. It's immense. So that really is something that we're going to change as well.
Wow. Yeah. I mean, obviously, TCO for these guys is, I mean, it's the peak. Yeah. It's what we're going for. So, Harmen, this has been fascinating. I really, really, truly mean that. I'm very interested to see, kind of the next step for you. What is your next step? I mean, what are you hoping to achieve, this year or, following year?
Yeah, obviously, no pun intended, get traction in the market. We are dealing with tier one top mining companies already. It takes a long time to nurture those relationships, and they're all interested, obviously, in the life-saving effect, and that's number one. So we want to get into the mine sites. That's the big one. Everyone wants to do their own validation on site as well.
Sure.
Once that goes, you go from 1 or 2 trucks into regional, or first local, then regional implementation, and really take over the world. Knowing, and this is my life mission by now, that this will take another 20, 30 years. The beauty of it's all retrofittable, so you doesn't have to come off factory.
Okay.
But there's over 70,000 mining vehicles alone in the world. So, it will take a while to make a dent in that. But yeah, that's really where we're going at.
That's fascinating. Well, Harmen, thank you so much. Really appreciate your time here today.
Yeah, no worries. Thank you very much for the invite. And I just want to mention one thing. We're a company still in the process of growing. So if people want to join the company, we actually do run investment opportunities as well. So yeah, if anyone wants to join, I highly recommend go visit our website and join the company. Now it's still open and possible.
Fantastic. That is exciting.
Thank you.
For sure. Well, thank you for joining us. Appreciate your time. Take care.